Looking at the second part of the proof, and that's to prove that variance of Tx. So that's what we want to prove in the second part. We have to prove that the variance equals t square to the variance of x. Okay, so here is the LHS, and this is the RHS. So I'm going to work from the LHS to the RHS for this, and we can therefore start by taking the variance of Tx, right, and understanding that that should be equal to the expected value of Tx, right, all square, minus the expected value of Tx. To make this better, and that will be all squared out. This is variance. Okay, so what we want to do from here is to look at this and split that up, and that will be the expected value Tx by Tx, and we can subtract that. We know that as a bracket there. That will be if you do this part here, if you simplify that part out, what you will get is you're going to get the t outside, the expected value, and then the x. You get that? And it's still going to all be in square. So what you get here is going to be t square x square, and then that will give you minus. In this way, it's going to be the t, right, multiplied by the expected value, multiplied by the t, multiplied by that'll be the t and the expected value. That's what square means. And in here you'll get t square, the expected value, all square, minus, in this case you get t square, and we get the expected value in its own bracket, which is going to be the expected value like that. We're covering it up, all square. Okay, so in here we can think of the expected value all squared out, right, is common, and we will left here with this all square, right, minus just this now, which is definitely going to be the expected value, right, and that will be all squared out. So if you simplify this, you will notice that this that we have here is the variance. Okay, so, and that will produce the t square by the variance of x. So that's proved. So we did that, and we were able to kind of get what we want out of the box. So there you go with the second part of the question. So in this part of the question, we are told to consider the following distribution below, and then here you have the distribution 1, 2, 3, 4, and then you have the probability distribution also given straight away. We have to find the mean yx. Okay, so it does not really matter, so we want to find the mean. So we know that the mean yx is going to be x multiplied by the probability distribution of x, right? And that in fact will be the summation, right? So we just have to sum that up, and that's going to be 1 multiplied by 0.2, and that will be plus 2 multiplied by 0.4, that will be plus 3 multiplied by 0.2, and that will be plus 4 multiplied by 0.2. So if you sum up this, that will be 0.2 plus 0.8 plus 0.6 plus 0.8. okay, and this will give you 1. This and this is 1. That's 1.8, and 1.8 plus 6, I will give you 2.4. I will give you 2.4. Then we can go ahead and figure out the variance